Now let's see this timestamp based protocol. It requires that ordering among the transactions is determined in advance based on their timestamps, that is, the time at which transaction enters into the system for execution. So what they mean to say is, we are going to order the transactions based on the time at which they enter into the system. So if you see this, let us say if you have transactions T1 and T2, and if both of them are going to enter into the system at different times, assume that all the transactions are entering at different times. In that case, we are going to assign something called as a timestamp to these two transactions, so that you will be sure about the order, right? Once you give them some numbers, the number in which, the lowest number means the least transaction and highest number means higher transaction. So I'll tell you why we are going to use it. Okay, so on the timestamp, that is the time at which transaction enters into the system for execution, and then each transaction is given unique fixed timestamp denoted by TS of TI. So TS means timestamp of transaction TI. So this meaning is, you are going to give timestamp that has to be unique and that has to be fixed. Now what is the difference between the time and timestamp is, let us say this transaction has entered our system at 9 AM, okay, and this transaction has entered our system at 10 AM. When they are entering at a difference of 1 hour, we generally don't go for concurrent execution, but just to make the point clear, I am just giving you 1 hour difference. Let us say it entered at 9 AM and it entered at 10 AM. Now what is the number that you should give to this? Either you can give them directly the time, which means you can say that the timestamp of this transaction is 9 and the timestamp of this transaction is 10, but then with a lot of transactions coming in, maintaining these numbers as exactly times may be not that practical. What we actually need is some relative numbering. Relative numbering means just the numbers which we assign to these transactions should be able to say which transaction has occurred earlier and which transaction has occurred later. That is the only thing that I want, right? Therefore, giving them the numbers which are relative will be simple. That is why we are calling them as timestamps and not as times, which means if you think that I'll start the system with, let us say, number 1 for the first transaction, and then any transaction that enters next, I'll keep on incrementing this number, then this transaction will get number 2. Now these two numbers are enough to just identify that T1 is the transaction which has occurred first or which has entered first, and then T2 is the transaction which has entered next. So even without having the exact times, by giving some relative numbers, I'll be able to say which one has occurred earlier. So that is the difference between time and timestamps. So this timestamp based protocol is entirely based on this concept. We are going to give some numbers to the transactions, and then we are going to order the transactions according to the numbers which we have given, and we are going to give the numbers in such a way that they will be in the increasing order at which they have arrived. So for example, if there is one more transaction T3 which has occurred after T2, which means which has entered after this, let us say it entered at 10:30. Now we are going to give it number 3. Now by looking at these numbers, I'll be able to say which one has entered earlier, right? Now the number 1 says that this one, see, timestamp of this one is less, therefore we can say that this is the earliest one which has entered, and then if the timestamp of this one is between these two, we can say that this one has entered between these two, right? And this one is highest, so we can say that it is the last one to enter, right? Now if you observe this TS of the this number, this expression gives us this. If I say timestamp of T1, then it is nothing but 1, right? And what is TS of T2? It is nothing but 2. That is what the meaning of this expression is. And now if any transaction Tj enters after Ti, the relation between their timestamps will be Ts of Ti is less than Ts of Tj. That is what they are saying. So if this one has entered after this, then timestamp of this one will be less than timestamp of this one. Timestamp of Ti will be less than timestamp of Tj, which means the resulting schedule must be equivalent to the serial schedule Ti to Tj. So the entire why we are doing this whole process is to make sure that the order in which you have given them these timestamps, we are going to generate the schedule or allow the schedule only in this order. So whatever order you execute the conflicting actions, by the final, the result has to be conflict equivalent to the order in which you have given the these numbers. So what I mean to say is, let us say you have given these numbers 1, 2, 3 to these 3 transactions, and you have executed the schedule in a non-serial manner. But then you have to write some algorithms, or you have to use the concept of this timestamp in such a way that the final schedule should be equivalent to the serial schedule T1, then T2, then T3. If you execute this serial schedule, and whatever you are going to get, the schedule in which you execute this, even though it is in a non-serial order, both of them should be conflict equivalent. That is the meaning of it. Now how to do that? That depends on you. Now timestamp says that the timestamp based protocols, the main concept is give every transaction some timestamp, and then you execute them. Now while executing, you have to make decisions about whether to carry out some action or not, in such a way that the result, the final schedule after execution, it should be equivalent to the serial schedule if you had run the schedule in the same order of the these timestamps. Got it? So in this one, the first one is, so how to do it, I'll just show you now. So there are two ways we can do it. So in timestamp based protocols, we have two variations. One variation is purely based on this timestamp, and the other one is Thomas Wright rule. So now let's see one of the variations, timestamp ordering protocol. Let's see this. Now timestamp ordering protocol. Timestamp ordering protocol ensures that any conflicting read and write operations are executed in the timestamp order. If not, such an operation is rejected and the transactions will be rolled back. The rollback transaction will be restarted with a new timestamp. So what I mean to say is, now let's see this. Let us say T1 and T2 are two transactions which you are trying to run. Assume that T1 is the first one to have entered the system and T2 is the next one to have entered the system. Let us say you have already assigned that timestamp of T1 is equal to 1 and the timestamp of T2 is equal to 2. Right? Now whenever there are conflicting actions that are going to occur, then you should see that the conflicting actions always occur in this timestamp ordering only. Right? Now what are the conflicting actions is, if you see this one, let's say the first operation from T1 is read of A. So nothing has been done, so allow it. And then the next operation that will be done in this schedule is W of A, right? So which means write of A. Now if you observe this, these two are conflicting actions, right? See, this operation is already performed. Now you have to decide whether you should perform this operation or not. At every operation you are going to take the decision whether should I perform this operation or should I not. Now in order to take this decision, you have to look at the timestamps. See this? Now the order is 1 followed by 2, right? The order of these conflicting actions is 1 followed by 2, T1 followed by T2, and the timestamp of this one is less than timestamp of this one, so you can allow it, right? So whenever the timestamp of this one is less than this, you can allow that. Got it? Which means the conflicting actions are also occurring in the same way in which transactions have entered the system. Got it? So if you observe this, T1 and T2, now you just see what is the transaction which has done this and what is its timestamp, and what is the transaction that is wanting to do this and what is its timestamp, and if this one's timestamp is greater, then you are going to allow it. Therefore according to that rule, this operation will be allowed, right? And now next one is, you have to decide whether this operation has to be allowed in the system or not. Now if you observe this, what is the conflicting operation with this one, right? Now the conflicting operation is 2 after 1, right? Which means a transaction whose timestamp is greater has already executed, and then the transaction whose timestamp is lesser is actually executing now. Therefore you are not supposed to allow it, isn't it? Why? If you allow it, clearly there will be a cycle, right? So it is saying that T1 then T2, it is saying that T2 then T1, so definitely there is a cycle, and now you will not allow it because the timestamps are not in the ascending order, right? Here, from here to here, timestamps are in ascending order 1 to 2, but from here to here timestamp are in descending order 2 to 1, right? Therefore you are not going to allow this. So at this point you are going to reject this operation, right? And you are going to roll back the transaction, right? Now what happens because of this rollback is, once you roll back, this entire transactions will be undone, and again you are going to restart this at later point in time. Then this particular transaction is going to get a higher this timestamp, which means if the timestamp of this one is 2, this one will get 3. And now if it tries to perform all these operations, it will be allowed to perform. Let us say you have cancelled it off completely, and now you are going to restart it here, right, as let us say T1 again. Now it will try to do the read here, and it will try to do the write here. Now this will actually be right now, because this one timestamp is 2 and the conflicting action timestamp is 3. This one timestamp is 2 and this one is 3. Therefore the conflicting actions are occurring in the increasing order. Got it? Therefore you can do this, right, at some later point in time, right? Now by writing like this, initially what we tried is, we tried to make this schedule equivalent to the serial schedule T1 followed by T2, but it was not possible. That is why I rolled it back, and now I am trying to make this schedule equivalent to the serial schedule T2 followed by T1, which will be true now. Got it? So somehow this particular timestamp ordering protocol is allowing us to run the schedules only if they are serializable, which means whatever schedule we are going to get at the result, as a result, is always going to be equivalent to some serial schedule. Otherwise the operations will not be performed. So here in this case, whenever you are trying to perform some operation, at every point you should stop and make a decision whether should I allow this operation or not, and that will be allowed only if the conflicting actions are in the increasing order. Otherwise it will be rolled back. Got it? Okay, let's look at one more example here. Now let us say T1 and T2 are in the system, and again the same thing. Now let's see one more example. In this example we have two transactions, T1 and T2. Now let's assume the same thing, which means the timestamp of T1 is 1 and timestamp of T2 is 2, which means T1 is the earlier one which has entered the system, and T2 is the last one to have entered the system. Now whenever you have given this one as 1 and this one as 2, we are going to see that the resulting schedule is always equivalent to the serial schedule T1 followed by T2, which means whenever there are any conflicting actions, they should always appear by the T1's actions first and then T2 action. Now for the first action there is no decision to be made, therefore allow it. And this one, as of now there is no conflict, right, because there is not a conflict, so allow it. And now for this one, should I allow it or not? That is the question. Now if you observe this, is there any conflict? Yes, the conflict is between these two, right? And now in these conflicting actions, which one is less? So if you observe this one, this T2's timestamp is less, sorry, T2's timestamp is more. Actually, if there are any conflicting actions, then the transactions which are doing this conflicting action should be in the ascending order, but here it is in the descending order, which means T2 is happening first and then T1 in this conflict, right? Therefore this one will not be allowed, and so you are supposed to roll back. Got it? Why? Because even though it is actually a conflict, it is actually a serial schedule, it is going to be equivalent to a serial schedule. The serial schedule to which this one is equivalent to is T2 followed by T1, isn't it? But then according to this timestamp ordering protocol, here we always order the timestamps, we always order the transactions in some order, and we try to produce the transactions which are conflict serializable to that order, which means in this one we are trying to execute the transactions so that the resulting schedule will be equivalent to the serial schedule T1 followed by T2. But here it is a serial schedule, it is equivalent to a serial schedule which is T2 followed by T1. That is why even though it is okay, still our timestamp ordering protocol will not allow it. So at this point it is going to reject it, and it is going to roll it back. So reject and rollback is going to happen, which means this entire transaction will be cancelled at this point, and again at some later point in time it will be restarted. Let us say after some time it has restarted, which one, T1 has restarted, and it is going to get executed, and at this point it is going to get a timestamp of 3, which is greater than this one. Why? Because it has entered the system again, therefore it is supposed to get a new timestamp, and that new timestamp will be greater than this because it entered at the last. Now at this point in time it will try to execute read A and then write A. and again there is a conflict, but then in this conflict you are having these timestamps in the ascending order, 2 then followed by 3, therefore it will be allowed, and also the resulting schedule will be equivalent to the serial schedule T2 followed by T1. Even though if you assume that there are even more operations, still it is going to be T2 followed by T1. Got it? Okay. Now how will you make sure that, okay, this is all about how the algorithm works. Now how does the implementation work? See, in the computer you are not going to draw the diagram this way and it is not going to test it this way. There has to be some other way, right? So that way is, for every data item, it is going to assign something called as what is the read timestamp and what is the write timestamp. For example, let's talk about this example. Okay, T1 followed by T2. In this case, A is being read by whom? T1. Therefore, in that case, the read timestamp for A, the read timestamp of A initially will be 1, right? And again, A is being written by whom? 2. Therefore, in that case, the write timestamp, initially all the timestamps will be 0, right? Write timestamp for A will be 2, right? And next time, whenever if some other transaction is going to write, so which means then it will see what is the timestamp of the transaction which is going to write. See, now if any transaction is going to write the same data, it will see that its timestamp, the timestamp of the transaction which is trying to write is 1, but already the write timestamp of A is 2. It means that a transaction with higher value has already written on that. Now if you are going to write this, it is going to be a conflict, and the conflict is in such a way that lower one is going to occur last or later compared to the higher one. So this is how your algorithm is going to be implemented, right? While coming to the implementation, how to do this is, for every data item we are going to maintain 2 timestamps. For every transaction we are going to maintain 1 timestamp, and for every data item in the database we are going to maintain 2 timestamps. One is called as read timestamp, other is called as write timestamp. Now read timestamp is always going to maintain who is the or what is the timestamp of the transaction which is largest that has read the value from A, and write timestamp is going to maintain what is the timestamp of the transactions which is largest which has read the value of A. Now by maintaining these two, we can see who has read it earlier, and now if I am trying to read it now, should I allow it or not? Got it? By using this algorithm will be implemented. Anyway, algorithm is not required for you, just remember that it can be implemented this way, right? So what are the main points coming to this is, we are going to use timestamps for every transaction and also 2 timestamps for every data item, and we are going to allow the schedule only if it is going to be conflict equivalent to the serial schedule which will be produced by the order in which we have given the timestamps. Otherwise we are going to reject the operation and we are going to roll back. Got it? Okay.